going to design a smart water irrigation system. The components that are needed to design the smart water irrigation system are Arduino L293 motor driver and the two batteries and the motor and the soil moisture sensor and the soil probe, and also the ESP8266 module. First of all, we should know about the connections. ESP8266, it is connected to the there are pins like VCC, TX, RX and the CHPD and ground. VCC is connected to the 3.3 volt of the Arduino and this CHP, and the TX and the RX pin are given to the pin 3 and the pin 4, as we did it in the smart water monitoring system, and also the ground is given to the ground of the Arduino. And next the motor is connected to the L293 motor driver, as positive is given to the MA1 and negative is given to the MA2, and the V minus of the L293 is given to the ground of the Arduino. And next and also the VCC and the ground on the other side of the motor driver is given to the battery. And next, the soil moisture sensor is connected to the probe. The polarities are neglected in this. There are no polarities. And next, the soil moisture sensor, there are 3 pins: VCC, ground and the A0. A0 is given to the A0 of the Arduino and ground is given to the ground of the Arduino. But the VCC, we will explain it later. Before that, the VCC, enable pins of enable and the input pin of the motor driver. Enable and the enable is given to the 5 volt pin. We will use a 3 pin terminal network, such as VCC of the of the soil moisture sensor and the L293D enable pin, both are connected to the 5 volts of the Arduino. And next, the input pin of the L293 is given to the input 8 of the Arduino. And next, USB is connected for the lab system for uploading the code. Next, we are going to connect this to the barrel connector, and we are going to upload the code next. After uploading the code, we are going to connect this battery, and using this motor and the tube, we are going to use it to pump the water system to the plant. Thank you.
Hello everyone, now we are going to design an Arduino code for the smart water irrigation system. We are including the function software serial.h, and we are initializing the values SR data and the PR data and the pump status. Software serial ESP8266 is 3,4, as we have given the pins to the receiver and the transmitter pins to the 3 and 4. This is included to connect the ESP8266 to the Arduino, and we are defining the value, defining SSID. It means the Wi-Fi name and the password for the ESP8266 to connect to the Wi-Fi. These are just defining the values, not connecting the values and not connecting to the Wi-Fi. The thing we require to connect to the Wi-Fi is 80 commands, and we are defining the function send 80 command in here. And next, this code is required to connect the ESP8266 to send 80 commands. And next, in the void setup, we are initializing some things like serial. We are starting the function, program in 9.6 seconds. And next, Wi-Fi module is connected, and we are sending the 80 commands. We are send 80 function to send reset 80 command, and next we are sending the 80 function to set the ESP8266 in a station mode, and CWGJ and JAP, it is connected to the SSID PASS. That means it is connecting to the Wi-Fi to the password. And next CFSR 80 command to CIFSR. It is required to print the IP address of the Wi-Fi which is connected. And next to set in CIP-MUX, it is required to set the ESP8266 to the multiple connections. And next pin mode is 0 comma input. As we have given the soil moisture sensor to the pin A0 for taking the input value through the soil moisture probe. And next pin mode 8 comma output, as we it is giving the index output. And next in the void loop we are SR data, as we have defined this the A0 as the input. It will read the sensor data, soil moisture data to the from the pin A0. And next peer data, it is remap the values SR data comma 0 1 2 3 1 0 2 3, and from low to high and high to low values from the current data, and also the giving the next values. And we are printing the sensor data and the PR data. And if PR data is less than 50, then digital write 8 comma low. It means it will be in off position, and else it will be in um, on position as a digital write 8 comma high, as we given the 8 pin 8 as the output. And next this is required to connect to the update the values for the thingspeak.com for every 2 seconds. Next, this code is required to connect to the ThingsPic string t, comma string p, and send it is 80 plus zip start. It will connect the TCP IP connection through the apthingspic.com. And next, it will delay 2 seconds. Next, we are commanding as get the output key. This is the right key. We should have to replace it with the available ThingsPic right key and field 1 T. So these are the values which are going to present in the thingspeak.com. And next we are sending the IT commands. /n is nothing but a new line, and we are printing the T and the P values for every 15 seconds. Thank you. And we are going to compile the code, and next we are going to upload it. Thank you.
We can see that the water is flowing through as the soil moisture sensor is giving the values.